Hi, this is Aakanksha Saha, and I'm going to present on the topic of graphical representation of statistical data extracted from logs using Plotly. So, short introduction about myself. Currently, I'm working in HP PPS R&D Hub in Bangalore, and I'm working with the team of LFP, known as large format printers. So large format printers are the line of printers which are used in technical, graphical, and other industrial segments. Some of their use cases being wall art, canvas, banners to film, printing photos, posters, and other technical drawings. So if I move on to the second slide, can you see? So this is the line of printers you can see. So the first of them is HP Designjet Printer, which is mostly used for graphical purposes like printing posters, and apart from that, it is used in technical drawings also. Moving on this line, we have HP Scitex printers, which are used for printing packaging materials and signages. So you must have seen the label on the Coca-Cola bottle. It is printed in such kind of printers only. And moving up, we have another line of HP Scitex printers. So they have a support of every kind of media. Media, in our sense, is the roll or the paper which we load. So they have multifunctionality and they support any flexible and rigid media. So you see, these large format printers are up and running for 24/7 and are known for their reliability, versatility, and high quality products. So with printers, consistent validation of changes done in the printer needs to be recorded. And this is not only for printers, it is generic for any embedded device or any other application or software you design. I would like to explain here with a small example of mobile phone. Let's say a company releases a mobile phone called version 1 in certain month. And it recorded that the switch on time of the mobile phone took 15 seconds in the first version. Moving on, after a few months, the company released another version of the mobile phone, let's say version 2, and it recorded that the switch on time of the mobile phone took 18 seconds. So you see, there is a delay of 3 seconds, and this delay is a very crucial, significant data for an R&D engineer or any other developer to study what all went wrong in the version 1 release to the version 2 release. Similarly, if I extend this idea in our area, developers look into certain significant data in the printers. We have the wake-up time of the printer. The wake-up time of the printer is the time a printer takes to wake up from the sleep mode. Similarly, we have the sleep time of the printer. So the sleep time of the printer is the time taken by a printer to go into the sleep mode. So these wake up time and sleep time of the printer are some significant values that an R&D engineer needs to study to see some anomalous behavior in the printer from one release to another release. So if I went on explaining, a printer has a lot of components. In our printer, we have heaters, we have motors, we have sensors, we have equipments. So when we say a printer is ready to work, when we say a printer has been woken up, it means that every component which a printer encompasses has been woken up. So let's say a printer has 100 components, and if I name them from C1 to C100, calling them C1 as the component 1 and C100 as component 100. So if all the components have been woken up, then only we say that the printer is ready to be used. So let's say a developer flashed some changes to the printer. It built some changes as in compiled, and it recorded the data in the logs, and it has come to his knowledge that a certain component, let's say component 2, took 200 milliseconds to wake up in the first change which he did. And we usually follow a weekly cycle, and in the second week, the developer made some other changes and it recorded that the component C2 took 500 milliseconds in the second change or the build he did. So this delay of 300 milliseconds is a crucial data which he would need to figure out what went wrong in from one build version to another build version. And it is very it's very important for an R&D engineer to know that there is some stability in the builds. So if we knew that the total wake up time of the printer was affected because the component 2 took 300 milliseconds extra time to wake up, so he would know which area to focus on and which coding module he should focus on to fix that problem or the bug. So it will become very easier for him to identify the area where he needs to concentrate. But you see that these all log data which we get from the devices are stored in a textual version. The developer, to see the log file, has to navigate to certain folder of certain week, and then he has to read that log file. And if he has to compare the log files, he has to manually do this thing. So it's a very strenuous task to manually compare the log files and see for the changes. It results in wastage of time as well as mental energy. So we decided to come up with an idea that how we can represent these textual data into graphical format. So our picture is worth 1,000 points, worth 1,000 words, a picture. So we can just, we can just represent these logs in a graphical format. It would be very much easier to examine and visualize the changes over a period of time. So on searching on a lot of tools, we came across this new library called Plotly. So what Plotly does is it takes the data and with as you can see in the workflow in the presentation, the first input which we are giving is the data values, which is in the form of a text file. So a text file has some data values which we are interested to study. So the text file contains week 1 and all the changes which we want to study, week 2, and then all the key data values which we want to study. Similarly, this contains all the week's value which we are interested to see. So this text file is then fed into the main code logic, which is written in JavaScript. So this JavaScript reads the text values from the file one by one, and then it passes on those values to the Plotly library. So this Plotly library finally gives the output in the form of a bar graph. So if you see in the results column, I have a bar graph represented there. We have an x-axis and we have a y-axis. The y-axis, I have shown all the key performance values which we are interested to study. Like we were interested to study the sleep time of the printer, the wake up time, the sleep time of supply 0, the supply 0 being the ink supply 0, and supply 1 is the ink supply 1. So we have these data, and I have used color-coded bars to represent the weeks. Like in my graph, as you can see in the results column, that blue represents the week 1 data, orange represents the week 2 data, and similarly the brown bar graph represents the week 6 data. So as you have seen, I have clubbed 6 weeks data, and I have used 4 main keywords to represent. So if you look into this graph, you'll realize that I can actually compare the sleep time of the printer for 6 weeks, and I can see that not all changes have been done from one week to another week. As you see in the first column, the sleep time of the printer was some 62 milliseconds. But in the second week, the orange bar graph, you can see it increased to 64 seconds. So there is a difference in the value, and it's very easier to visualize and see that what all differences occurred over a period of week when a tester or a developer do some changes in the printer. So owing to these things, the outcomes which we got after representing the log values into graphical format were that it was, of course, it made our life really easier to analyze the numerical data and represent in bar graph. Moreover, if you want, you can also change the mode of the graph. Since Plotly, we chose Plotly because it suited our needs and it was aligned to our requirements. But you can also, and the best thing about this, we can change the mode of the graphs. So here I wanted the bar graphs to be displayed. One can also use line graphs, scatter plots, or any other histograms to represent their values in a different graphical format. So this has a very great flexibility. Moreover, this tool supports any number of input data. So here I'm studying for just 4 keywords. If you have more number of input data, you could just feed that into the library. If you want to study for, let's say, 10 weeks or 20 weeks, you can just increase the number of bars. So it supports a lot many number of input data representation. Moreover, this tool made it easier for not only for technical people but also for managerial and non-technical people to examine and review the data over a period of time. So it helped in more in-depth discussions. It helped in the presentation of our anomalous behaviors. It helped in an ideal way to visualize, and communication was made much more interactive after representation. After we represented the things in a graphical manner. Moreover, it proved to be a powerful way of communication when you show multiple pairs of comparison. Instead of going through different files again and again to see what all comparisons we need to do, we can just represent in a graph and we can just see in one go that what all changes have occurred over a period of time. And other benefits which Plotly give is we can download this graph as a PNG and we can save it in our hard disk. We can send it as an attachment. Moreover, we can zoom in, zoom out of this graph, and we can just we can change colors, we can change titles, we can mess around with data, and we can embed these static plots in any of the web contents. So as you see that this tool makes communicating ideas and scientific analysis much easier and effortless. So we opted for it, and we were able to get very good results after this. This has helped our team a lot, and I hope if anyone wants to use it in future, they can go ahead. So if you have any queries related to it, you can just drop me a mail. That's all. Thank you.